Okay, today I'll be showing how to approximate pi using a unit circle. We'll first start out with a polygon, then go to a hexagon, then a dodecagon, and so on. First draw a unit circle, and then draw an equilateral triangle inside the unit circle. And then draw from the center point of the triangle to one of the angles, and that'll be the radius of the circle, so that'll make this 1. And then we want to draw a line perpendicular to this line that will bisect it, so draw right there. Okay, so we know that this is a 60-degree angle and that this line bisects it, so that'll make this a 30-degree angle. And that'll make, with this being perpendicular, make it a right angle, and leaving this to be 60. Okay, from there, of a 30, 60, 90 triangle, a shorter leg will be a half, and that'll make this root 3 over 2. And since this bisects it, that'll make this root 3. So then we know for the perimeter that this will be 3 times root 3. Okay, now moving on to a hexagon. We know that that this is, okay. So yeah, we'll draw a line here and bisect this, making this root 3 over 2. And then we know that this is a 60-degree angle and that this arc will be twice of this angle, so that will be 120. And then subtracting that from 360, we'll get that this is 240. And dividing that by 2, we'll get that this is 120. And since this line bisects that angle, that'll make this 60. And this will be a right angle because it bisects and is perpendicular. And that'll be this to be 30. Okay, so now using the cosine of 30, we'll get that cosine of 30 is equal to root 3 over 2 over h. And multiplying both sides by h and dividing it by the cosine of 30, we'll get that root 3 over 2, or root 3 over 2 divided by the cosine of 30, which will equal 1. So the perimeter for the hexagon will be 6 because it's the number of sides times the length of the side. Okay, now moving on to a dodecagon. Okay, extending this line here, we'll get that this arc is twice 30, so that'll be, this arc will be 60, leaving this arc to be 300. So with that, then that'll make this angle here 150, and dividing that by 2, because it bisects, will make this 75. This is a right angle because it's perpendicular, and this will be 15. Okay, so since this bisects, that'll make this a half. Now using the cosine of 15, we'll get cosine of 15 will equal 1/2 over h. Multiplying both sides by h and dividing it by the cosine of 15, we'll get that h equals 0.5 over the cosine of 15, which is 0.5176. And multiplying that by 12, we'll get the perimeter for the dodecagon.
6.211.
Should be 6.1
No, 2, 1, 1, 2.
1, 1, 2. Okay. And from there, you can, for a unit, or for the circumference of a circle, it's 2 pi r, and for a unit circle, the radius is 1. So you can see that with the perimeters, we're getting closer to 2 pi each time. Now, we also see that this was a 60, so, and this was a 30, and this is a 15. So we know that the angles are halving each time. So the next one will be the cosine of 7.5, and it'll be, this was 0.5176 right here, and we're bisecting it there. So that'll make this 0.2588 over h. So multiplying both sides by h, we'll get that h equals 0.2588 divided by cosine of 7.5. And that will be
0.261.
0.261. And multiplying that by 24, we'll get that the perimeter is
6.26.
6.2647. Okay, now you can see that that got closer to 2 pi. Now moving over to Excel. You can see that the number of sides doubled each time, that the angle halved each time. We moved it over to radians to find the side length, and that the perimeter gets closer to 2 pi each time. And because the unit circle is 2 pi, we divided it by 2 to find the approximation of pi. And you can see that here, that 3.1415926535879 is really close to pi. We have a chart over here to show how close that it gets. But at some point, cosine will just become 1, so that will be a limit for it.